There's also traffic control, smart roads, smart lighting. I can go on and on. It's all about the money. And IoT revenue forecasts in 2020 from a variety of sources range from US $1.2 trillion to $4.5 trillion. This is for the year 2020. With a forecasted value somewhere between $1 and $4 trillion, IoT will have a collective value similar to many of the world's leading economies, such as Germany, Brazil, and UK. Gartner estimates that by 2020, consumer spending, in fact, will surpass enterprise spending to become the largest spending category in the IoT space. So who's capturing this value? As you can see on this chart, by 2021, software and services will account for roughly 55% of IoT spending. Spending on hardware and connectivity, which in 2018 represented about 45% of the total spend, is going to continue to shrink. The money that will be captured will be primarily in software and services moving forward, because hardware prices will continue to be driven down, and connectivity price likewise will continue to go down. This is an impossible to read eye chart. The point of this sea of logos is simply to convey the scale of the IoT startup activity just in North America. As of last spring, there were almost 3,500 IoT startups in North America across 3 broad categories, those being connected apps and processes, connected intelligence, and connected edge. These 3 categories are further refined into 6 segments containing 31 subsegments. So let's look just at one category. Consider connected and autonomous things within the connected edge category. Within this space, Read-Write Labs identifies 5 subsegments: wearables, robots, vehicles, drones, and machines. And in this space, there were last year 412 startups, and that number has surely grown in the last half year. IDC forecasts that IoT investment through the period 2017 through 2022 will hit 1.2 trillion. That's a compound annual growth rate of greater than 13%. Discrete manufacturing and transportation will each exceed $150 billion in spending in 2022, making those 2 sectors, manufacturing and transportation, the 2 largest industries for IoT spending. By 2025, the potential economic impact of IoT is forecast to range from $2.7 trillion to $6.2 trillion. Only the mobile internet and the automation of knowledge work are expected to have a greater impact than IoT. In fact, the low estimate for the economic impact of IoT in 2025 is $2.7 trillion. That amount is more than the total economic value of the next 8 technologies combined, excluding cloud technologies, since I consider cloud and IoT to be synergistic. So what are the catalysts for the growth of IoT? There are a number of factors as reflected on this chart. Microprocessor costs continue to slide. Memory costs likewise are falling. There's a proliferation of new IoT sensors, and the prices of these sensors themselves are falling. Connectivity costs have plummeted. AI, artificial intelligence, is rapidly evolving. And finally, a variety of low-power wide-area networks are being deployed alongside cellular networks, such as LoRaWAN. So what are the benefits of adopting IoT? Where do companies expect the biggest payback from IoT? A survey done by Raconteur indicated that 25% of companies believe their customers will pay extra for premium services and support. 22% of companies believe better and more cost-effective products and services will attract new customers to their businesses. 18% believe they can create efficiencies that will reduce their cost base. 16% of companies believe they will retain customers who would otherwise walk away, in effect reducing customer churn. A similar number of companies believe they can resell valuable data to third parties. I believe that the top 3 benefits listed on this chart, in fact, are the real near-term drivers for IoT growth. Better collection of accurate data and business insights, reducing costs, and improving employee productivity. IoT is still a very nascent, very embryonic industry. Many companies begin their IoT journey with great expectations. And like many great expectations, they end up being disappointed. Gartner recently estimated that through 2018, 80% of IoT implementations will have squandered their transformational opportunities and failed to monetize IoT data. A similar survey by Cisco found that 1/3 of all completed IoT projects were not considered a success. So what's got to change? 3 things. Companies need to develop a partner ecosystem. No one can do it alone. IoT applications, IoT solutions require a number of partners to collaborate. Companies need to improve their talent management strategies and hire and develop people that are expert in IoT-related technologies. And finally, companies need to focus on the business challenge and not the technology. At Itron, and the purpose of this presentation is to talk about IoT and not about Itron. Itron is an AMI, Advanced Meter Infrastructure and Smart Cities solution provider. But we provide solutions. We're completely technology agnostic. We develop solutions for customers based on their requirements. And that's what needs to be done in the IoT space as well. Companies are planning more POCs, proof of concepts, but many companies have tempered their expectations about the pace of adoption. Today, in the IoT space, most companies now are focusing cautiously on simple IoT applications. Simple tracking and alert functions are relatively easy to deploy because they do not require advanced analytics. They do not require complex algorithms or data science capabilities. Thus, by focusing on these relatively simple tracking and alert functions, they can generate value more quickly. Although some innovators are enthusiastic about IoT applications for optimization and prediction, we believe that most customers will remain focused on simple use cases for the immediate future. The transformational nature of IoT will drive everyone towards more optimization and prediction such as prescriptive maintenance. Another eye chart. The purpose of this graphic is simply to demonstrate that the competitive structure is shifting as established OEMs and suppliers scramble to capture value in the IoT space. OEMs are acquiring service providers. Witness Itron's acquisition last year of Silver Spring Networks that positioned Itron in the smart city space. In the systems and software space, consider ARM's acquisition of Treasure Data last year, as well as IBM's recent acquisition of Red Hat. Established players and partners need to work together, and IoT and artificial intelligence and must work together in order to speed time to market. Time to market is everything. The sheer amount of time and investment required for developing advanced IoT AI solutions can be prohibitive. Therefore, partners across technologies, markets, and use cases must work together to ease the burden. This chart shows the value curve for IoT, created by IoT Analytics. Today, most organizations, most IoT applications are in the early stage of this curve. In the area of digital monitoring and controlling. The real value of IoT will come as applications mature and you have ecosystem enabled and optimized systems. Manufacturing, transportation and logistics, and utilities are the most mature of all of the sectors in terms of this value curve. By the way, the position on the curve isn't intended to say that manufacturing is necessarily ecosystem enabled quite yet. 5G is coming. Network slicing and cloud native approaches will allow 5G to support everything from data-intensive short-range communications to low-power distributed sensor networks. 5G will enable differentiated network capabilities. 5G has the ability to serve diverse network requirements across many verticals, leveraging network slicing to support 3 core use case families: enhanced mobile broadband, ultra-reliable low-latency communications, and massive machine-type communications. Personally, 5G is going to take much longer to become fully deployed than most OEMs and service providers want you to believe. Also, this chart, which was created by Harvard Research, suggests that all other connectivity solutions are going to fade away. That's simply not the case. There is not a silver bullet connectivity solution. LoRaWAN, Wi-SON, other low-power wide area networks will persist for a very long time. So what are the characteristics of 5G, though, that make it so attractive? There are a number. It offers ultra-high broadband speeds, massive connectivity and capacity. In 5G, you'll be able to accommodate concurrent connections up to 1 million devices per square kilometer. 5G will be much more power efficient. It'll provide ultra-high reliability, super low response time, meaning latency will be very low, higher data rates, and low costs. All of the performance factors that I just mentioned are at least one order of magnitude better than what we experience today in 4G networks. Big numbers are an integral part of any IoT discussion. Here, Harvard Research projects 30 billion connected devices representing a US $2.4 trillion revenue opportunity by 2025. Looking further ahead, my former employer, ARM Holdings, at the recent ARM TechCon conference in San Jose, published a jaw-dropping projection of 1 trillion IoT connected devices by 2035. That's a staggering number. The global internet connected population in 2001 was just 500 million. By 2016, the global internet population had grown to 3.6 billion. In 2001, broadband penetration was just 10%. By 2016, it had grown to 25%. In 2001, the global smartphone penetration was barely 1%. By 2016, that had reached 40%, and today it's a much higher number than that. There will be over 20 billion IoT. There will be over 20 billion IoT devices by 2020. And by 2020, 90% of all automobiles will be connected to the internet. What are we going to do with all this data? Even with 5G, can the networks accommodate such a massive amount of data? The answer is no. Intelligence is going to have to move from the cloud to the edge. And what I'm calling the empowered edge. Edge technology will gain strength in the coming years. Edge calculations will happen as close as possible to where the data is generated. Information will be processed on the spot. Results, reports will be communicated to the cloud, but actions will be taken locally. Edge technology is important for the development of IoT. This allows connected devices to communicate with the analytic system without delay and eliminates dependencies on IP connections. Improved edge computing plus increased power of devices plus the emergence of ultra high-speed connections will accelerate the development of edge technology and the deployment of edge technology. Edge computing is going to keep growing. Edge computing and the cloud will be synergistic. 5G is the ideal environment for connecting millions of edge devices. Sending enormous volumes of data to cloud is simply not sustainable. Device-to-cloud data communications is constrained by latency, bandwidth, and cost. Distributed cloud and computing models will enable intelligent processing at the network edge. As shown on this graphic, processing is going to move from the cloud closer to the edge, and you will also see processing done directly on IoT devices. So let me talk about a use case that combines many of the things that I've discussed so far. One of the companies that I work with is an IoT startup. It's called Econo. It's a 1.5-year-old company that's based in Sweden, and it's a machine learning software startup. Keep in mind, it's only a 1.5 years old. Today it consists of 12 people, and last month they closed their post-seed round of financing, raising roughly 2.3 million euros. They are working today only with companies in Sweden, since it's in their backyard, and Sweden is blessed with a disproportionate number of multinational global companies that are very well known, considered Volvo, Assa Abloy, and the company shown here, Husqvarna. Husqvarna is a leading producer of outdoor power products and other innovative products for forest, park, and garden care. Husqvarna's products include robotic lawnmowers. They're also known as automowers. Husqvarna was founded in its namesake town in 1689. Husqvarna this year celebrates its 330th birthday, which to me is a stunning accomplishment. To continually and successfully reinvent yourself into its 4th century of existence. That's quite an accomplishment. So what we see here is one of the robotic lawnmowers. This robotic lawnmower has artificial intelligence on it. It has machine learning software. It's very easy to install. You take it out of the box and turn it on. It has the ability to self-monitor itself and provide predictive maintenance, thereby extending the life of the product through better maintenance. It can optimize its own performance and save 30 to 40% of energy. It's a very intuitive product. It also has a lock-in effect because this lawnmower learns your lawn area and learns how to optimally cut it. It learns when to cut it. It will turn itself on and off and recharges itself. And it also, from a Husqvarna perspective, has the advantage of, in effect, locking in customers. Because in 4 or 5 or 10 years, whenever the lawnmower has to be replaced, the learning that it's been accomplished with that lawnmower can be transferred to the new auto lawnmower. You're unlikely to go out and buy a similar product but from another company if you can't transfer that learning. Husqvarna has sold over 2 million auto mowers. Edge machine learning helps them learn from each individual garden to run it in optimum. They run when needed, they save plenty of energy, and there's no need to program the lawnmower. These learnings, as I said, are then transferable to the next generation lawnmower. So, smart industry means that each individual component must become a little smarter. It makes the whole process much smarter, and this is done using machine learning. Icono's machine learning is also being applied today by other Swedish manufacturers to pumps, to welders, to paint machines. The machine learning allows these devices to understand the context, their specific environment, individual conditions, and differences. It enables the entire process to become really smart. Machine learning at the edge solves 6 problems. By using machine learning, you learn from data instead of programming conditions, and you have the ability to predict the future. We've learned cloud for 15 years. Now it's time to learn the cloud edge interface. Cloud is good for presentation everywhere, comparing across the installed base and fleet management, and for manual analytics, but there are some challenges. The volume of data. Sensors on an airplane can generate 2.5 terabytes of data per day. All of it is valuable, but most of that data has a very short best before date, where the conclusions or learnings are more relevant to store than the raw data. Good data. Solution to the volume challenge is that blunt minute, hour, or daily averages are sent to the cloud. Processing all the high-frequency data in real time on the device instead enables detection of even small deviations and changes in trends. Also, you avoid the latency factor incumbent in communicating with the cloud. Connectivity. Many IoT devices are mobile or deployed in locations with poor or unreliable connectivity. Being autonomous and acting locally reduces this dependency. Data integrity. Aggregating data comes with a big cost and responsibility today. GDPR rules in Europe set requirements. Customers will not allow every vendor to upload and store data, and the enterprises themselves are concerned with potential data leakage. Econo does machine learning for IoT for edge-based machines. Their solution came out of a university at the University of Borås. It is sold as an embedded software solution. It makes connected things smart, enabling predictive maintenance, performance optimization, intuitive products, and the introduction of data-driven business models. What are the most significant barriers limiting IoT adoption today? Vendors need to address several barriers, especially security integration and unclear returns on investment. Companies in the IoT space need to focus on getting a few industries right. Focus on 1, 2, or 3 domains. This allows the vendors to acquire and apply significant industry expertise and provides a competitive edge against more generic offers from other providers. Vendors need to develop end-to-end solutions. When vendors focus on use cases particular to an industry, they learn about different data sets required, the sensors measuring it, and how to process and glean valuable insights. From this, they learn what's transferable to the next customers. Vendors can create standard packages, reducing customization requirements, shortening sales cycles, and increasing the likelihood of success. They can prepare to scale by removing the barriers to adoption. Understanding the customer's pain point is the first step. So, this is my last slide. How do you capture IoT opportunities? My recommendation is focus on outcomes. Don't focus on technology. The author Douglas Adams is quoted as saying, "We are stuck with technology when what we really want is just stuff that works." Both developers and business leaders often focus on the technological potential of the IoT, including its ability to collect and analyze vast stores of data. But technological advances alone will not make an IoT application more valuable or more desirable to customers. Instead, developers must focus on outcomes, how any new application will improve safety or financial returns or convenience. I could go into great detail about GE's experience with airplanes, with Boeing's experience with airplanes, but I think that we've already covered much of that. So, as companies shift their focus from technology to outcomes, they will need to provide incentives that encourage upstream vendors and customers to support the use of their applications. They need to design for people, not just for enterprises. Just as innovators tend to focus on technology, many IoT marketing materials try to appeal to customers by discussing the latest product upgrade, including better sensors, better connectivity, computing power, and analytics. But experience has offered one insight. Users, both consumers and industrial users, are more likely to adopt IoT technologies that generate a positive emotional reaction. So with that, I will close. We have a few minutes and perhaps we can take a couple questions. If no, Mark, there's a mic if anyone wishes to ask a question. All right, then let's wrap up this portion of the presentation. I want to thank you for your time and your attention.
Is there any questions? There is a mobile mic here.
Let me thank first Mr. James Edson, who deserves a warm applause. He's coming from San Diego. Thank you. So we'll have the Q&A session, Mr. James, if you'd like to stay with us a little bit. Is there any question or comments, if you like? So thank you for your time-sensitive approach and the practical approach. And if there are no questions at this point, I would like to invite you to the coffee break and the exhibition. We will be back at 9:30.